Basically, I have between 2 and 3 years to write a report about the condition of the natural resources in Big Cypress in Everglades National Park. How the quality of that report will likely depend on the ability, on how well I interface with you all. So that's why I wanted to take this opportunity to introduce myself. What it is, NRCA is really a synthesis of what you're seeing today, stated very concisely, meant for the audience of policymakers and the public. It's supposed to give us the opportunity to have a high-level synthesis of what's going on, and if we do a really good job, we can maybe say why things are going as they are. It has a wide variety of expected uses, particularly to support formal planning and to support the creation of resource, to support the creation of resource stewardship strategies that are occurring over a 10 to 15-year time horizon. So the idea is that the NRCA is really right around here. It's a synthesis of syntheses, if you will. The sound science. I'm a scientist, but in my background, I love the practicing. I love the practice of science. What I found is it's very difficult for non-scientists to understand what we're talking about often. So I think the value of this process is that we can continue to do what we love to do because we're understood by a broad audience of people. And what we do has an impact on their decisions. There's one layer which I hope we get to is when we have a very sound and solid discussion, we can create resource condition summary or resource briefs. And these go to, these are very specific high-level summaries that usually happen right before significant decisions made. So if we do a really good job, we'll be operating here and here. NRCAs are multidisciplinary. They're flexible instruments, and they should and will be tailored by the priorities of the superintendent as well as the resource managers of Big Cypress and Everglades. NRCAs must be useful, and they give us an opportunity to really customize our message and potentially innovate, become more innovative in how we're reporting about the relationship among key indicators. There are some examples of groups of people who've been attempting this process. This is a very challenging process. The ecological indicators for South Florida is a good example. This is about the level of summary one can expect to see. The system status report. These are two documents that I've had at least peripheral involvement. I've been deeply involved in this for the last 4 years, and I've used this as a product for the last 4 years while I was working in the Comprehensive Everglades Restoration Program supporting the Army Corps of Engineers. The idea is to boil them down to this level of summary, how concerned we are and how are things changing. I think this is best done in the context of a hierarchical discussion where we're focusing on an organism or we're focusing on an indicator of interest. We also are able to have a fluid discussion of what's driving that, what is the actual processes that are local processes that are affecting this indicator, as well as what are the broader landscape scale context So you can see the indicator can be affected by sort of bottom-up processes or top-down conditions. This has been a very interesting find, this paper in the last few weeks. And I think this is probably best understood. I think this is my last slide. Second last. This process is probably best understood by the story of the parable of the watchmaker, right? There's two watchmakers. Each one of them has to do a very develop a very sophisticated project. All of them get called and they get interrupted over the course of their career, and they only get to go so far. One of them tries to create a whole watch every time and never quite gets it done. The other one tries to construct their watch in modules and is able to assemble several watches over time. And I think that NRCA, it's going to happen on 2 to 3 year intervals. I think NRCAs have the ability to become useful immediately when we focus on synthesis between individual indicator components, and we build this process, we build a modular process to yield a clear and comprehensible result. This document can say not only this is the status of the resources, it can also say we don't know anything about this resource and this is why. So, we're really, my intent is to be supportive of the scientific community and to help clearly communicate to managers and policymakers of this is what we know and this is what we don't know, so they can make decisions about how to allocate their resources toward either monitoring and confirmation or research and discovery. This is an example of how the Heinz Center reported their process. The Heinz Center really is the model that this is based on. If you just put in Heinz Center 2008 in Google, you'll discover this report very quickly. Thank you very much.
Hello, my name is John Kellum. I'm a biologist here at Big Cypress National Preserve. And since 2007, we started a Big Cypress fox squirrel study here in the preserve, and I would just like to go over the preliminary findings to date. All kinds of technology here. So Big Cypress fox squirrel, which are an endemic squirrel which live primarily south of the Caloosahatchee River, all the way down through the southern peninsula from near Everglades National Park up to Fort Myers and all the way over to the western edge of Palm Beach County. Are disappearing in the periphery of the range in South Florida due to encroachment, development, habitat fragmentation, and loss. And in the core of the range, which includes Big Cypress National Preserve, their status is unknown. They were once a game species, but now they're listed as threatened in the state of Florida. Previous telemetry work has been conducted in urban areas, primarily golf courses. There's been several studies in the last 15 years, and they've all went and tried to catch squirrels in the wild and ended up having to go to places like golf courses in Naples where there are viable populations of urban fox squirrels. And therefore the ecology of the species and natural habitats is poorly known. Pretty much all the research to date's been on fox squirrels in golf courses in Naples. In 2002, the Fish and Wildlife Service declined a petition to list the Big Cypress fox squirrel as a federally protected species. And the main reason was a lack of knowledge. They're saying, look, you have all this public land, you've got the Fakahatchee, you've got Panther Refuge, you've got Corkscrew, you've got Big Cypress National Preserve and Everglades, and it looks like there's a lot of forested land there. You don't know anything about it in the wild, so we're not going to list it. So in May of 2007, Deborah Jansen, the preserve's wildlife biologist, encouraged me to start a Big Cypress fox squirrel study. And since we started efforts, we've managed to catch and handle and radio collar 10 males and 10 females in the Raccoon Point area of Big Cypress. Outside of telemetry data, we collect plant composition, habitat usage, hydrology, nest relocations, diet, and behavioral observations directly related to each squirrel within their individual home ranges. So, in the very beginning, Deb says, I'd like you to start a study. And so, we had an historic map here, and I'm going to use a pointer this time. Break the tradition here, I usually point. So, here's 41 right here, there's 29, and there's 75. It's a lightsaber. So if you look at some of these dots here, there's dots down here on the loop road, right in this area. This is the Monument Lake area right here. And one place I noticed was there was a cluster of sightings in the Raccoon Point area. There's a couple things that make it unique. First of all, there's a road here that provides access. Secondly, it's one of the few areas in the preserve where there's old growth pinelands that have never been logged. And thirdly, it's the site of a long-term fire ecology study. So there's a known fire regime, and the pinelands there are very healthy and mimic natural conditions. So just another perspective of where it's at. That's Raccoon Point. This is Big Cypress National Preserve. That's Everglades 75 and 41. And this is the 25 square kilometer study area. These are pads. These are oil pads. Some of them are active. And it looks like there's a lot of impact to the area. However, outside of these roads, once you step off and once you walk out off the road, it is just like going back in time. It's very pristine. It's like a primordial swamp. It's a mosaic of habitats. Let's go back to that one. It's a mosaic of habitats, and one thing you'll notice is these little circular things are cypress stones. Areas like this are contiguous pinelands, and it's just a real neat mix of pinelands, cypress stones, cypress strands, prairies, hardwood hammocks, and areas that we call pine forest with cypress associates, which is basically a combination of cypress and pines, usually on the edge of strands and domes. So here's a pineland. Here's a cypress dome. This is the cypress strand. This is a hardwood hammock. Though I believe that tree is in Everglades National Park. Don't tell anyone. And here's a pine forest with cypress associates. I kind of threw this slide together last minute, and here's a pine tree, other pines, we have cypress. There's also a big rat snake here. And if I have more time, I don't. Actually, there was a squirrel. We have a video of a big cypress foxtrot being in the cavity, and some of the field technicians who monitored my squirrel actually saw the snake poke its head in, and it heard the squirrel chatter. And I said, okay, that's an interesting story. Until I found the video a couple days ago. They actually videotaped the squirrel chattering, so it's a neat video. So I chose Raccoon Point. First thing, I read all the literature, and the literature says they live in the pinelands. They're pretty much a ground-dwelling species. So I started going out doing reconnaissance in pinelands. If that's what everyone else, if that's their ecology, well, then that's the best place to start. So I went out to pinelands and spent weeks out there doing reconnaissance and was looking for things like pine cones. Once I found an area, I also in the literature read that they use, let's say, pecans up in Delmarva for Delmarva fox squirrel projects, or they use corn cob in Georgia, or in Florida they might use peanut butter combination. Why decide? Let's just throw it all together and see what we can get. So I ran these trap lines out in these nice pinelands, made it easy so they weren't far from a road, and you'd leave a little bit of bait in front. You'd wire them open, and you'd put bait in front, and then over time, this is like a week before you actually want to try and start catch them, you would put bait out in front, and you slowly move it back in the trap until like the morning before. It's still wired open the day before. You put food actually right on the pedal that trips the trap door, and then the day we actually trap, you arm it. So after weeks of dawn until evening, we finally managed to catch a squirrel. And here's a beautiful big cypress fox squirrel adult, and we consider this a black morph, even though those are orange. One thing between all the color phases, they have white nose and white ears. Here's an orange color phase. Once again, notice the white nose and white ears. And then here's what we call like a blonde, and they have, some of them are really blonde, and then also there's a myriad of colors in between. There's like grizzled colors, but one thing to note is that they all have that very distinct head. And also the size, the adults are twice as big as gray squirrels, and twice as long. So the next question is, okay, we caught some squirrels, but through monitoring we started noticing signs of activity. If you want to catch a squirrel, well, you got to go where they're at. You can't just conveniently go along a road. So what do you do if your sign is in waist-deep water in the middle of the dome, a mile and a half from a road? Well, we wanted to catch squirrels. So what I devised was, it's like a hamster jungle gym. And I actually carried hollow core doors with the help of Deb and Ralph Arwood and Annette Johnson and the Hinsons and a myriad of other people. And I build these platforms out there. I find out where the squirrel activity is, and I would go, okay, well, this is where the activity is, build the platforms, bungee the traps down, and then I create lash from here, a long board over there, and a log over to here, to where another nest was. And I made a connection, and I rubbed peanut butter all down the line. I tried to entice them by putting corn nuggets here, and then I slathered peanut butter here and here, and just was like, come on guys, let's do this, you know? And that's like a smaller platform. The doors, we'd actually put the traps back to back. And my whole theory is, why have a small platform? You want to encourage a squirrel that may have food, like the cypress cones up in the canopy. Why would they want to come down to the ground? If they have plenty of food and cover everything they need. So I wanted to provide an environment that would, maybe they might feel comfortable standing on, like, look at that big object, and it's got duff on there, and look at all that food. So either way we caught them, the first step is to cover the squirrel to calm it, and then we go over the order of operations, because based upon our state permit, we're limited amount of time that it takes to handle. Our goal is to be under 8 minutes. And then here's our collar. It's a 11 3/4 gram collar. We put surgical tubing so that the collars do not abrade the neck of squirrels. And once we do have a squirrel in there, we affix a handling cone, which is a Velcro cone on one end. And then what it is I've got the back door open, and I've got a cone on it, and I'm going like this, and I make a eye while I'm watching, and then Deb will lift this up, which allows light in, and I call this encouraging the squirrel to enter the cone. Sometimes light will do it. Sometimes you'd be surprised. You just lift up the towel, the squirrel seat gets the light, and the cone acts like a darker cavity, which it feels more comfortable in. So the squirrel will just turn around and walk right in. Other times it's not like that. So once we get it inside the handling bag, first thing we weigh it, and then we sex it, which can be very difficult. And then we used to insert a pit tag in the beginning. We're like, oh, we don't know if these collars are going to fall off. We don't know if we're going to have failures. If we pre-catch squirrels in the future and the collar falls off, we don't want to lose all that potential data. So we put a pit tag, which is very similar to what we do. It is what we use for panthers and what people use for pets. However, we do not lose collars. Our collars do not fall off. And we've had very good success. And so we stopped doing that because we felt it was undue stress on the animal and increases handling time. So the next step is, once you weigh it and sex it, is you put a hood on it. And there's holding the squirrel. And then you carefully size the collar. There's a real scientific method to it. It's a pen, is what was recommended by Dr. Kaprowski. But also, I'm not going to simplify it. It's very important if you have a juvenile squirrel. You don't want the collar to pinch the animal. It's a real feeling. I always erred on the side of caution. I'd rather have a looser collar than err and have a restricted collar that can hurt the animal. So sometimes I look at Deb when we're releasing and go, I feel really good about it, but you know what? If it falls off, it's a good thing. So carefully size the collar, and then you crimp it, and believe me, I do not want these things to come off because they're so hard to catch. So I crimp it as hard as I can, and then you release the squirrel. And just quickly, we learned a couple techniques. When we first started doing it, what we would do is, we would, like, okay, ready, and then I'd have the hood, or Deb would have the hood, or whatever, then we would, like, pull the bag away from the animal, then pull the hood. Well, the animal can feel its legs are free, so it would already start winding up. So by the time you pull the hood off, it could be turning towards you, and we have photos of it lunging like a lawn dart towards Deb and bounding off her chest in the bushes. So after a couple times, we realized the way to do it is you pull the hood off, and then a fraction of a second later, boom, you pull the bag off, and then they can see where they want to go, and they go away from you. So that was a discovery. There he goes. And there he is. So if you're looking at an 850, 900 gram animal, 11 3/4 gram collar, isn't that intrusive? And you wonder, well, look at that collar, it looks like it's crimped around its neck. Well, Fortunately, we were able to catch, for recollaring, the squirrel, which is fox squirrel 298, wore that collar for 2 years. And as you can see, I'm pulling it back. There's no abrasion, no hair loss. I have another photo that shows that when you release the fur, relax it, there's no harm to the animal. And the animal, had a normal weight. So I feel very comfortable that it's not invasive. We developed a monitoring schedule. The goal was to go monitor the squirrels 1 time per day, 3 days per week. And to minimize data bias, we set it up to like between 7 to 10 in the morning one time, 10 to 1, and so on and so forth. However, I do want to state that certain times of the year, especially during the summertime, we have big thunderstorm buildup for safety reasons and other reasons. It's just better not to go out in the afternoon and go stand in water in your waste. So there is a bias towards the first couple between 7 and 1 o'clock. As soon as we started monitoring squirrels, once we worked out a monitoring schedule and go to the wood, the first thing we realized was, wow, what's that up there in the dome? And we started seeing, what is this material? And, that must be a fox squirrel nest, because we're going around a tree and that's where the squirrel was at. And then you can see here's another one. This is a Bromeliad Atlantia, and there's actually a little opening on this one. And this is one of the 2 most common styles of nest. This is a Bromeliad with striped cypress bark in it. The next style is a stick nest. And here's Dennis Giardino actually took this photo while up in the canopy. I'll get to that later. But it's a stick nest. If you look up here, there's striped cypress bark on there. Here's another photo. Stick nest, sticks, striped cypress bark on top. And you'll note there's a fox squirrel tail here. And a couple of my volunteers are very happy to finally get a photo of the white-tipped squirrel, because this is like a ghost up there and we were hoping to get a picture of. To get back to strip bark, when you go out in the woods, it's another way to tell if there's sign. How do you know where squirrels are at? They're secretive. They're not like gray squirrels. They don't come and chatter at you. As a matter of fact, you walk in an area and they don't, they're silent. They'll go on the opposite side of the tree, or they won't move, or go way up the top and they don't chatter. So if we go in an area and we start seeing strip bark, we start looking up for nests. Another thing it's good for, it gives us the indices of how fresh activity is. How recent the squirrels. If you can go to a dome and I get trapped, I'll go into a mile square area and look to trap for an area to trap squirrels, and it'll miss. No nest. Well, you can find a dome that has 6 nests in it, but if they're old, you're probably not going to catch a squirrel there. If you find the 1 nest that's really fresh, you'll probably catch a squirrel there. So Ralph Arwood took these. This was taken on January 23rd, 2008, and 1 month later, you can see how much it's oxidized from bright orange to that gray color. There's other type of nest types. Here's a nest that was in a bromeliad, but it had Spanish moss woven into it. Here's another style. It was reported to me that the squirrel was in here somewhere. I blew the photo up, and what do you know? There's striped cypress bark right there. And of all the 350 nests found in the Raccoon Point study area, this is gorgeous pinelands, and it makes up a large percentage of the overall available habitat type for the squirrels. There's only 1 nest we found in a pine tree. 1. And lets you know the importance that cypress is to the squirrels in their natural environment in Big Cypress Swamp. Sometimes, this is Dennis Giardino, who's our lead tree climber on our panther capture season. And when we're up catching panthers, or hunting panthers, I should say, up in Raccoon Point, sometimes I'll be like, hey Dennis, I got a pine tree. I don't know if it's a squirrel nest or a bird nest. And Dennis volunteers and he'll go up, climb the tree and look and see if it indeed is a squirrel nest or a bird nest. Also, on one occasion we had a mortality signal coming from a nest area, and we wanted to recover the collar. And Dennis went up, and he's the only person I know of that's taken a above photo of nests. He climbed up the tree, and this is looking down on it, and here's another view. You can see his legs there in a row. So it's really beneficial to be able to say, indeed, we've only had 1 nest in a pine tree, and we verified the other ones that we thought might not. All nest trees get a tree tag. Also, and we don't know if they nested them, we have documented squirrels being in defects in cypress trees. Here's another one. This is the tree where the snake was on it. You can see a squirrel had chewed right here. Also, in pileated woodpecker cavities, you can see the chiseling on it. We've had squirrels go in there too. We do not know if they're nesting there, and it could be just that or go in the area to monitor and they run in a hole. While monitoring the nest, sometimes you get a really neat experience, especially if you're like Deb and you go sit out there in the beautiful evening and sit there for a couple hours. You get photos of here's the head of the mom, and here's the body, and there's the tail. Then here's a little baby leaning up here, and there's the head of another squirrel, and here's another one up here. So here's a little family of squirrels. So it's the only photo we've gotten outside of Ralph Harwood. So we told Ralph about it, and Ralph brings his camera up, sloshes through the swamp, and goes takes this picture. And this is one of the same little young squirrels there, and here's the same thing hanging out looking at Ralph. So Ralph is always a great asset to have to not only document scientific things like the sex of squirrels, but also to just capture moments like this. How am I doing for time? I got 5 more minutes? I'll go fast. Yeah, I'm sorry. Okay, this is one of our male Big Cypress fox squirrels. It's a mosaic of habitats. This is, he has 349 locations. That's 349 days we've gone out and located them. His 95% MCP home range is 389 acres. So that's a pretty large area. Then if you look at the kernel home range, the 50% MCP is here, and you wonder why, and this is the yellow is the 95, and this orange is the 50%. Why is there such a cluster here? Why is there so many locations there? The answer is these are nest trees that we found while that squirrel was alive within his home range. There's 139 nest trees. We don't know how many of those he used, but we do know he used 40 of them. The red trees are the 40 trees that he used. And if you notice, there's a big clustered nest, and that's what really dictated his home range. Okay. I was just going to compare his data. If you look at 389 acres, 133 for the 95%, and for the 50, 12.8 acres. When you compare it to two other males, the MCP home range and the 95% kernel are smaller on the 2 other ones. Well, that's because they have about 25% of the locations. So what it is this is an old sample. I haven't had time to analyze all the data. We just finished this part of the study a few months ago, so I just had time to look at one squirrel, 916, and I'm comparing it to some old data. So we have many other squirrels that have hundreds of locations, but I haven't had a chance. But what I'm doing is a real quick comparison, and what I want to show you is that, and here's some females with less than 100 locations, is that females on average have about 1/3 of the home range size. The 95% MCP, they have 1/3 of the 95% kernel and 1/3 of the size of the 50% kernel. So if you just want a quick overview, preliminary finds are showing that their home range in all aspects is around 1/3 the size of males. Almost done here. Here's the 5 habitat types that are found in this mosaic. If you look, 80% of 916's locations were found in cypress domes. When you compare that to those 4 other squirrels I mentioned, their average was 73%. So fox squirrels are primarily described as open pineland ground dwelling species. However, 97% of the nest trees are in cypress trees, and greater than 73% of all the telemetry habitat type locations were in cypress domes. So our preliminary findings are saying that cypress domes with good foraging habitat is the most important Big Cypress fox squirrel habitat component within Big Cypress National Preserve. We've documented 12 different types of food items, and the most important being the seasonally abundant cypress stones and pine seeds. And here's a photo of Big Cypress fox squirrel carrying a pine cone. Here's a cocoa plum, I believe. And this is a debate whether that's hawksplum or persimmon. I'm leaning towards persimmon. And here is they love tillandsia buds, especially it's like a family food for them, even though I do say cypress stone. They'll go up and clip off the stems and they'll actually eat the tillandsia. And here's cypress cones, one of their beloved main food sources. And another interesting thing we found is here's thistle, and we go out and find them where they cut them off, and you can see the angle of their teeth, and they drop it, and then they eat the seeds from it. So we've learned a lot about their diet, and I could go on and on, obviously, as you guys can see, about it, but I got to end here. So management implications. So far, what we've learned is how do I, this study will document the ecology of the Big Cypress fox squirrel here in the preserve. But not only that, it's the first real glimpse of their home range and habitat use throughout their range. All the other data has been from golf courses, so it's really exciting. We're right on the cusp. We have all this raw data of really starting to analyze it and see what we have. Another thing is that we're able to, through this, we're going to be able to identify suitable fox squirrel habitat based on vegetation characteristics maintained by prescribed fire. Because prescribed fire is the #1 management tool we have to maintain these healthy ecosystems for not only the fox squirrels, but all the other species that use the same habitats. And also, this study is also yielding new techniques to determine fox squirrel occupancy in habitats throughout the reserve, which may be important. What the next step for Big Cypress fox squirrel research is to figure out occupancy. We need to determine where the squirrels are at. It doesn't do you any good to say, oh, that's 726,000 acres, there must be millions of squirrels. We need to find out where the squirrels are here, where they're Fat-Ganchi, where they're at Panther Refuge, Corkscrew, Everglades National Park, and so on and so forth. So we're developing, I see as the genesis of techniques of how to find them, how to capture them, how to locate them, and provide useful information, and that hopefully we can develop relationships with universities and start really branching out and get to know about the squirrels. And that's it.
So I'm a postdoctoral research associate at the National University and National Park Service, South Florida Caribbean and Victoria Monitoring Network. And it's a mouthful. And I've been tasked with setting up a long-term vegetation monitoring program for the network for all the parks here in South Florida and the Virgin Islands. And to this end, one of the things that was done before I arrived was to catalog all the past vegetation monitoring and research projects that have been done in the parks. And one of the particularly interesting ones that we have picked up is the one that was set up by Lance Gunderson and Lloyd Booth with the assistance of others at the South Florida Research Center. This original project was conducted between approximately 1980 and 1982 in the early years of the preserve, and they established 5 square kilometer study areas that were representative of the larger preserve. And these were Deep Lake over here, Turner River, Raccoon Point, Cell 28 tieback area, and then Pinecrest down here in the southeast. And they made hand-drawn vegetation maps from aerial photographs of these 5 study areas. And then they included in each of these a number of 15 by 40 meter vegetation plots that were in the dominant vegetation communities within each study area. So the first step in resurrecting this project is relocating the original plots. And lucky for us, they were very meticulous about this, and they put in concrete markers on all 4 corners of the plots, because they intended that these be surveyed repeatedly over time, but they were lost about 2 years ago. Also, fortunate for us, they included primitive GPS coordinates in most of the reports that they wrote about this project. And from the vegetation maps, they had marked where the plots were approximately on the maps, and they had a pretty good cartographer. So once we scanned and geo-referenced those maps, they were actually pretty close. So we were able to find most of these plots fairly easily. However, that was not always the case. So we are still missing a few. To date, we've attempted to find 13 out of the 19 vegetation plots. We've successfully relocated the sample 10 of them, which are represented by the pink circles now, where the yellow ones are the ones we have either attempted or not found yet. So now I'm going to present to you some of the interesting results from each of the different sites and some overall trends that we see for these 10 vegetation plots and how they've changed over the past 30 years. So Turner River was the first site that we surveyed. And we see here an increase in tree abundance and density, represented here by that's proportional to the elevation gradient for pine plots, number 1, 2, and 3. 4 here is different because it's a cypress strain, and there's much change there. Most of this increase in tree basal area is actually the cabbage palm. And it's probably a similar situation as to what Larry described this morning, this afternoon. So we've seen a huge increase in the abundance of cabbage palms. However, when looking at just the pine trees, what's interesting at this location is we're seeing this right here at all three plots. So we're seeing a low number of old individuals, which closely match the original data, and then we see this new group of recruits separated by some time. There are a couple of possible explanations for this. Probably the most likely, based on the age of the oldest trees and the new group of adult recruits, if you use the aging information from plat studies from Everglades, these trees are about the same age as the time that they stopped logging in Big Cypress in the 1940s. This could also be the recovery signature of some other type of disturbance. It could be maybe hurricane, it could be fire, or it could just be representative of a change in environmental conditions that promotes the growth and improvement of pine trees. What's also nice to see, and it's highlighted here in the table, is we're seeing an increase in the number of species that we're finding in the herb layer in most of these pine plots. This is also true at pine plots and cypress plots at the Raccoon Point area. We're seeing this significant increase in the number of species that we're finding in the herb layer. And this could just be time since disturbance. We don't know the disturbance regime here. This could have just been a longer time period for this sampling event than the original sampling event. Or it could be that conditions are changing that are promoting the coexistence of species in the herb layer. It's hard to tell from such a small sample size. We're seeing something very interesting happening at the pine crest site. Over here I've got herb cover between the years and between the two sites there for cypress prairie. And the colored bars here represent different species, and the size of the bar, the abundance of that species. And if you'll notice, the top half of each bar across sites and across years is fairly similar. What's different is the blue section at the bottom, and this is the abundance of Schizocarium rhizomatum. So what we're seeing here in the cypress prairie plots at Pinecrest, so we're seeing a shift from a sedge-dominated community, primarily of Angospora species, to a grass-dominated community, to this increase in blue-stem grasses. Corresponding to this increase in herb cover, we're seeing a decrease in the overall richness of the herb layer, possibly because of competitive exclusion from the increasing cover from the grasses. Now there are two, or the most likely explanation for this pattern that we're seeing here is time since disturbance. From the original report, I know that these two plots were located where they were so that they could be surveyed in conjunction with a prescribed burn experiment. And so this survey was done shortly after a burn in the area. And the increase in grass abundance could be just a natural progression of time since disturbance. Or it could be indicating a shift to drive a shorter hybrid period situation. Some overall trends that we're seeing across plots and across sites is overall an increase in total herb cover. We're seeing that at 7 out of 10 plots across all sites, particularly in the Turner River area, where we see the pine plots had this significant increase in total herb cover, and with that, a significant increase in the number of species in the herb layer. We're seeing an overall increase in shrub cover at 6 out of 10 plots across 2 of the sites, particularly in the Raccoon Point area. Raccoon Point 1 and 2 are the 2 pine plots here, and there was a significant increase in the cover for Sable and Serenella palm species. But also here we're seeing some juvenile pine trees that are starting to invade the cypress prairie plot, and a lot of juvenile cypress in this is available. The final analysis, and the third time you've seen this today, I guess I'm jumping on the back of this, is multi-dimensional scale and ordination analysis of the relative abundance of species of these different plots. I did this for 1982 and 2010, the Bee survey, to see how well these communities cluster with one another. And if you look at this, you can't even see the individual plots because they cluster so well. All of the plots are stacked right on top of each other, and they fall right into their communities. Final plots stacked right on top of each other. Cypress prairies and domes almost identical, and the strands quite a bit different because of the inclusion of a lot of hardwood species that don't present in the domes. And then I took this next step and compared the coordination from 1982 to 2010 using the Procrustes analysis. And so the circles in the center at the beginning of the vectors here are where the community started in 1982. And this shows you the trajectory of communities over time from 1982 to 2010. And you can clearly see that even though the communities still cluster fairly well, they're diverging from one another over time. And I can tell you anecdotally from the original reports and what I know about this, because we didn't collect any environmental data, but this seems to follow a relative elevation gradient. These three pine plots over here were our highest relative elevation. This is moderate relative elevation. And our Turner River 3 was the lowest relative elevation. And if you notice, this the trajectory of this plot is headed in the same direction as the Cypress strand for the wetter community. Also, over here with the Cypress prairie plots, the Raccoon Point Cypress prairie plot is diverging from those found at Pinecrest, which is actually not too far away. And it's headed in the same direction as the pine plots, because since 1982, there have been the appearance of a number of small adult pine trees that appeared in that Cypress prairie plot. That's shifting that community in that direction. So as for the future of these legacy plots, they are going to become a permanent part of the SFCN Forest Vegetation Monitoring Program. These are it's very comparable data that they collected, and we will continue to collect here to what's going to be our core forest monitoring plots. And this extends our time frame by about 30 years. It gives historical context to some of our future monitoring in the preserve and what trends we might find. And we plan on resampling these approximately every 6 years, along with our core forest vegetation monitoring plots that will be established over the next 6 to 7 years. So lastly, I'd like to ask those of you who work in Big Cypress Preserve if you have ever seen one of these monitors walking around, or if you find yourself working in the backcountry here in the preserve frequently, and would like to help us find the remaining 7 plots, please come and talk to me. We'll be working on that this winter, but we can always use your assistance. And with that, I'd like to thank those that contributed to this project and helped us for us today.
A little bit different subject. Mike, Owen, we need to talk. You know, we live so close together, and you keep saying, Mike, come on up here, and, well, I never invited him right there. And I need to go down there, it never happened in Orange for 20 years. So, you know, we have a lot in common, and it's really good, it's refreshing to see how this work works going on. So I'm remiss in my first talk, I'm showing slides of fire and the red cuttated woodpeckers. And that was actually to remind me that when we're cutting cabbage palm, or looking at the causes of the need to do these different things, we're using this process called adaptive management. Big fish and wildlife service term. It means go out there and make your mistakes and then fix them. And so while we're doing these different management tools, management techniques, I've got Wade back here, and Angie, it's her last day. She's going to Nevada. And then Heather and Sonia doing bird surveys, and I can't remember anything else. A whole bunch of stuff, and plus years of research by different people. And that to segue into the research we've done in orchids for the last 12 years, actually 12 years, working with orchids through the University of Florida and Illinois College. Illinois College, if you look really hard, up at Jacksonville, Illinois, and of course at University of Florida in Gainesville, and of course you can see the perspective there with the We've been here since '89. It was Bob Reed who walked into our office one day and said, "Hey, you're a new refuge. I know where you have some orchids." And I, orchids? What's an orchid? so he took me out there and he started to, and he was the one that taught me how to pollinate a cigar orchid. It's really easy. You have to hold your tongue like this. Of course, we've located maybe 30 species of orchids, Fakahatchees up in the 40s, and we're jealous. Of course, you've seen this picture at the bottom. This is another place, this top picture here. Yes, poaching is an issue. People love to steal orchids, and I'm really sorry that somebody would actually rip off a cigar orchid. I'd like to catch that guy. Really bad. And but looking at all the issues that have gone on in this last century, logging certainly in the 40s and 50s with the cypress, huge devastating effect it had on certified cigar orchids, but also agricultural issues, urban development, and the Panther Refuge stands to become an island in the near future with approaching development, parking lots, road surfaces. And those are issues. Illegal collecting on the Panther Refuge doesn't happen all that much, unlike Fakahatchee where I can still sneak down there and steal away. But the biggest thing, as I said in the cabbage palm talk, it's water. Water is the main driver, I think, in this ecosystem, if not for most ecosystems in the world. You know, once in a while we light the wrong kind of fire, the wrong kind of day, the wrong kind of place, and so non-beneficial fires, you know, we burn up an organ or two, especially certified. And then of course freezes. That's my current pet peeve. So looking at integrating orchid conservation research here on the Panther Refuge, we kind of go by this map here, looking at propagation science, pollination biology, mycology, study of fungi that actually is what is responsible for orchids. Because orchids have no energy source themselves. You need that fungus that actually germinates and feeds that germinated seed. Of course, ecology and distribution, plant reintroduction, genetic diversity. Fortunately for me, when I first started checking out what we might be able to do in terms of restoring orchids on the Panther Refuge, I met Scott Stewart at the University of Florida and then Dr. Mike Kane, who just about runs that department, horticultural, environmental horticulture. And, you know, I wanted to go out and get a bunch of seeds, get a bunch of orchid medium, commercially made orchid medium, forget fungus. And I will have, you know, been Johnny Orchid Seed in a year, and we would fix all the world's problems. Boy, that went out the window real quick. You know, we're just now to the point where we are producing large numbers of orchids via sterile flasking with. We produce a lot of agar, which grows fungus. We don't grow orchids. Fungus grows orchids, and that's how we grow them. And anyway, so all these things together is leading us to recovering some of these species, and particularly the research that we do that lead to research in the different kinds of programs that we're doing. The pollination biology, Scott Stewart working there on wild cocoa, seed germination under a microscope, that's what those little suckers look like. Habitat characterization, huge deal, because if you don't know where you are, you don't know what you can grow. What do you have to grow with? And then of course, now doing the different kinds of plant reintroductions that we're doing with these little quadrats that are wired off, so we're planting. This is actually an orchid right there. It's going to be Calipogon tuberosa simpsonii, one of the rare varieties that we have. And figuring out if they'll come back the next year, you know, what do we have to do to reintroduce these and be able to walk away from an area and know that we've done something that has some decent longevity. Pollination research has been fascinating, especially with Certipodium. You know, it has, you know, when we first started looking at it, a lack of capsule formation. And it wasn't that many years ago, Dennis and Mike were out on the refuge, and you came across an orchid with 2 seed capsules on it. And it's like, that's just huge, because year after year we look at these orchids flowering, and the orchids wither, the flowers wither, and you know, that's it. And then we, you know, of course, started mixing and matching pollen, finding out that indeed there must be some natural pollinators out there, and we actually have looked into that as well. You know, when you take Certipodium with very little capsule formation, Eulofia alta, every flower turns into a capsule. And identifying those breeding systems, those, you know, the various mechanisms for pollination biology, identifying the pollinators, it has been fascinating for me, you know, sitting back and acting really as a broker, giving money for pollination research. We actually discovered the bees, which means you get a really hungry, crazy graduate student that doesn't mind sitting in the middle of the woods in an easy chair in 6 inches of water, waiting for that bee to come along, and hopefully she's fast enough with a camera, which she was. They actually photographed some bees doing the thing, and that looks like just a European honeybee there, but I'm not sure. And that, in contrast to Eulofia alta, doesn't, you know, requires pollen transfer, but we can't even find out how that's going on. Is it an ant? Is it whatever? And these are fairly common orchids. More common now that we've removed the cabbage pollen because we have more sunlight to the north, so that's been good. And then looking at pollination biology of Certipodium, you know, figuring out this breeding system, knowing that with this particular species, you have to have 2 distinctly enough plants that where you can take pollen from one and bring it over to another. Yes, Franklin, that's what we do. Franklin has actually an orchid. He stole it from the Fakahatchee years ago. No, you got it from the Conservancy. Yeah, so, and they got it, yeah. And actually, before Franklin got it, I was out there at the Conservancy climbing that gumbo limbo and pollinating them for years. And I guarantee I smoked a cigarette after. I don't know about you, Mike. Okay, so, you know, you figure this stuff out. Danielle Dutra, who was actually from Brazil, doing her PhD work at the University of Hawaii now. Her thesis, by the way, won the IFAS annual award they give for the IFAS students to the University of Florida for her work on this. And we would actually pollinate as many flowers as we could, up to about 6 or 7. We got one inflorescence with 6 capsules forming on it. And which is interesting. I was telling Steve and Tony earlier, you know, you pollinate all these flowers, you come back a week later, and yes, this one took, yes, this one took, and you go, there's going to be a lot of weight on this inflorescence. So after about 2, by the way, 11, 12 months of full maturity of these capsules, I mean, that's huge. So, you know, we end up wiring these inflorescences so that they won't collapse. And in a natural system, you wouldn't see that. You wouldn't see a lot of pollinators out there pollinating a lot of flowers because you wouldn't have any capsules forming because they can't handle the weight. So really, when you look at how these tremendous number of flowers are really attractive, they really smell nice, but there's only so many pollinators out there that actually come into them, if they do at all. But when they do, it's 1 or 2 capsules here and there, and that's great because as Mike said, 3.5 million seeds. And I think it was Bob Reed that might have done that.
Wow.
But,
Larry, what's the bag there?
Ah, the bag. Okay, so what we do, it's a pollinator excluder. So we self-pollinate. We take a flower and we identify that flower and how it is exactly pollinated. Where did the pollen come from a different flower, from that plant, from another flower, from a different plant. And so we do all these things, and it's a really nice routine system of recording how you pollinate all those flowers so that when you do get capsule formation, you know exactly what did it. Was it a pollen from another plant? Well, these need to be outcrossed, and you can't have really related certipodiums doing it. So we actually doing a study looking at it, that it's almost done. We've sampled the DNA of these guys, and OJ did do it. So we can identify these individual plants now. So I mean, DNA, it's cool. Right? So we figured this out, and then Daniela comes along and asks if she could take an inflorescence back to the University of Florida. She does. They put it in a bell jar for 24 hours. They suck the smell off. They run it through a gas chromatograph, and you get the identification of all of these different long-chain hydrocarbons that make that smell. That's cool. Well, so a couple of years later, we did it, actually 2 years, not last summer, but the summer before. J.J. Sadler and Jackie, can't remember Jackie's last name, Illinois college students came down for the summer. And it's good to get them when you're an undergraduate, because they're cheaper to bury. And especially from Illinois, because you tell them we don't have mosquitoes here, and they believe you, and they don't realize it. So anyway, so they, in the field, without removing that GO circuit from the tree, from the plant, would actually put this bell jar over it. You notice this is a Rube Goldberg method of holding your bell jar up. Yeah, you need more string, JJ. No, I got plenty. And he hangs this bell jar up and encapsulates that GO circuit, seals the back end with an oven bag because they don't gas off. Hydrocarbons are a big deal. And then in 2-hour intervals from orchid flower to flower to flower, they would vacuum off the smell, go to another flower, do that for 2 hours over a 24-hour period. So these guys were really good up. I'm not sure JJ is quite normal. And anyway, so bottom line is this is the volume, representative volumes of each of the different hydrocarbons that we developed that are in the smell. And then this is actually the gas chromatograph, and they use this mass spectrometer there somewhere. I wouldn't know one of those grasses that are in place. But anyway, so here are the actual chemicals themselves, and then we actually ordered. Apparently there are companies that sell long-chain hydrocarbons, and you just order whatever you want. And then we use those relative volumes. We came up with our own formula. We mixed it together, and we had Ghost perfume, which is really cool. We're not quite right on it. It smells like that's cool, and you don't get mobbed by moths. Yeah, when you go outside. But anyway, all right. So changing focus just a little bit. Calipogon tuberosus. We've got a variety of Simpsonii. We've been looking at how to long-term storage of these seeds using cryogenic equipment. How we get, I know Mike used to work at the Disney Preserve. Mike, yeah. And you have, is it tuberosus or multiflora up there? Both. And you have far more orchids that would come up after a fire up there, I think. Not here, and we don't know why. We've been looking into that, but also we have a rather unique subspecies that we're looking at, Simpsonii. And then again, in these studies, particularly now with epiphytic species, we took 2 seed capsules from yellow helmet orchid. We produced 1,800 seedlings. We've been planting those out in experiments. Far too many orchids of one species to put in any place because of the potential of swamping the gene pool. That's a big deal. And I know we have to be careful of that as we start reintroducing the orchids. But in doing so, we're looking at survivorship, survivability, where we put them on a tree, and we figure that stuff out. We know how to hang an orchid on a tree. By the way, 6-inch wide, 50-foot roll, gutter mesh, and a hammer staple. If you want to hold up any orchid, you put that around the orchid, you staple it, you walk away. You don't have to use, yeah, see? It was so easy. Cheap. We did everything cheap because we want third world countries to be able to do it. But anyway, we figured out a lot of that stuff, and I say we, it's the folks that have been working out here. And of course, propagating by the thousands. and we use fungus, which we now grow to propagate everything. Bleedy purpurea, another cool example. We have two populations of blue dots, and now where we cleared out the cabbage palm here, I've got bleedy purpurea that's starting to migrate out in here, and hoping my sprayers that are killing cotton grass don't spray that out. But then, and you see the certipodium we have here, Dennis and Mike found that one, and then we've got a fairly good population over there. Eulofia alta, looking at just similar populations on both sides, comparing the various site classifications, soil and vegetative community around it. Cool stuff. You know, it's originally I thought it was gee whiz research. You know, oh yeah, it's good to know. If you want to reintroduce orchids, you got to know this stuff. And fortunately, I have people that override me with it. And just to kind of finish up here, outreach is the biggest thing because one, you have to tell people this is really complex. And yes, you could do it at your house. You could go down to Home Depot or Lowe's and you can buy those orchids that are, you know, stolen in the Philippine jungle or something like that and hybridized. This is the real deal here, and it's, for me, it's like panthers. The issue with water, the issue with ecosystem services. Orchids tell you a lot about what's going on in the environment, as do panthers. And for me, that's really important because if I want to, you know, save our ecosystem or help save this ecosystem, having an eye on the various elements that make up that ecosystem, especially panthers, especially orchids, I have a lot better chance of doing the right thing at the right time. I wanted to show you this. This is just over a 20-month period. Just University of Florida researchers, they were putting out a paper like once a week. Okay, well, they're just a bunch of paper-happy, crazy people. Yes, they're crazy. But we were just uncovering all this new stuff, just tons of new stuff. And I'll show you some new stuff. Oh, yeah. Anyway, yeah. Simpsonii on the left, and only one place in the refuge. The orchid on the right is multiflorus. I found it one time, 1 year, one place. I've never seen it since, but I guarantee it. It's there, it's alive, it's living underground because of the fungus that feeds it. When its shoots aren't above the ground, absorbing solar radiation, photosynthesizing, it lives underground, like a hermit, with fungus. And one of the dingy orchid, butterfly, and what's that one? Clam. A unique species of clamshell we have here in Florida. This was cool, and this was, you know, years ago when I wanted to take a picture of orchids, I didn't want any bugs on it because bugs aren't right. Well, it turns out bugs are everything. And this particular species of ant here is actually an exotic, but we found out in one of our places a lot of our orchids were getting hurt really bad by exotic scale insect. And their population was probably kept down a little bit because of this guy who was mining the honeydew that comes off the scale. So here's an exotic scale, exotic ant living in Cochrane Lake, you know, doing their thing. And then I started recognizing ants everywhere. Flies. I took this with you, Mike, a long time ago. And this is when film was still popular. And then butterfly orchid. Mosquitoes, I have no idea. I have more questions certainly than I have answers, and I think we can all say that, and that's what we do. And then this was really cool. I was with Daniela Dutra. Her undergraduate professor was an entomologist. She knew a lot about ants. And I was showing her how I could take a stick and rub that stick right underneath behind the flower right here. And then, because that's where the ants would come out on the stem, and they would just lock themselves up and be nursing on this whatever, some kind of pore, an EFN, extrafloronic nectar, that was oozing some kind of sugar that would keep the ant there. I would take and rub my stick there when they would leave periodically, get off the flower. I'd rub that stick all over the flower. When the ants came back out, these are like 3-inch bull ants, and they would walk all over the flower following the smell that I had wiped all over with my little stick. But ultimately, it ended up going back to that little dippy back there and nursing on the sugar or whatever that was being exuded. And I told her about this. She says, yeah. I mean, I know everything. So when I was talking to her, she, you know, are you an idiot? Yeah, I was just kidding about knowing everything. She said they're guard dogs. She said probably what they're doing is they're attracted to that flower, not to the flower itself, but out. They never really go on the flower. I got them there. I want to take a picture. But anyway, they go to that EFN, and they're there. So when an inchworm or something else walks out, crawls out onto that flower to do its thing, eat that flower, they gotta go up against a big frickin' ant. And why? Because they're not there for the flower, they're there for the food source. Yet, this is a night-smelling orchid. It doesn't smell during the day, it smells at night. And those guys probably help keep that flower there, unbeknownst to themselves, for that moth to fly in to do its thing. What does the moth get out of it? You figure that one out. I don't know yet. So anyway, just to end up, conclude, did I talk too long? What do you think, Larry? By way of advertising on December, you're good. You're really good. On December 2nd and 3rd at Botanical Garden, on the 2nd of December at Botanical Garden, we have our first ever orchid conservation conference. And you're all invited to come, bring $45. Actually, you have to do something more than that. You have to register through University of Florida. I've got some flyers back there. If they all run out, if those run out, I got a few more here, plus you can email me and I'll make sure you get the information. It would be really good if we had people participate in this because we're going to spend a day at the conference. We're actually going to flash some orchids using fungus, which is really cool. And then on the Saturday, we're going to go out to the refuge and see what we're doing. Thank you very much.
Thank you, Larry. Rebecca Outman from the University of Miami. No hurricanes.
I'm Rebecca Outman. I'm from the University of Miami, and I'm a graduate student there in the biology department. And we're going to give a presentation on some of the preliminary results of a project that I have. And keep in mind, this project is ongoing, almost finished, hopefully. But the results are not complete yet, so I'm just going to produce what I have so far. And also, this is kind of going to be bare bones. A lot of the details might be left out, so if you have any questions, feel free to email me or talk to me about anything you might think you missing. So South Florida is where I have done all of my field work so far. And Florida is the state with the highest bird diversity of any other state in the entire country, except for Hawaii. Doesn't exactly count when you compare to the rest of the country in the United States. So it's been known for a long time that Florida is really special when it comes to ferns. And part of the reason for this diversity is we have a lot of unique habitats here. And also, with the state, in South Florida, we have a place where subtropical species can actually exist. And then we also can have temperate species. So that accounts for a lot of the diversity. There's species here in South Florida that can't grow anywhere else. And these are just two native species that I didn't. So there's a lot of threats to native ferns in our state. And a lot of things that have gone on in the past dealt with urbanization, changes in hydrology. But one of the big threats now that actually seems to be increasing, unfortunately, is invasive species. And so my study is focusing particularly on invasive fern species that are displacing the natives from their habitats, as well as in some cases hybridizing with them, which is messing up the genetics of the species and in some cases kind of absorbing them. And this is just a photo of what people might have unfortunately seen like hoodie microphyllums. This is the most aggressive invasive currently in South Florida. There are others that are causing a lot of destruction as well. So what I wanted to look at is what types of environmental factors are allowing these invasive species to come in and be so successful, and what is allowing them to outcompete native species. So what I've started to focus on for this project is arbuscular mycorrhizas. So this is a really important biotic factor in a lot of ecosystems. And just to give a quick overview of what they are in case people aren't familiar, they're microscopic soil fungi. They form mutually beneficial associations with plants. Current estimates are 80% to 85%. So I put 80, but generally they're very important for plants. Some plants can't survive without them, and they help the plants absorb increased amounts of water and increased amounts of key nutrients, particularly phosphorus, but also nitrogen. This diagram on the side is just kind of a stylized diagram of the different ways that the mycorrhizas can appear within the root cells. So this is one of the images from my microscopy data. So it's known that ferns do form these associations with mycorrhizas and pretty broadly across species. And it has been known that a lot of the species grown in South Florida do form them. So I verified that in my study and found the particular structures that exist across many of the species I tested. So the species that I decided to go with, I took pretty common natives that grow across a wide range in South Florida, and I paired them with closely related invasive species, or non-native species. Not every single one is listed as invasive. You can see the status here in the right column. So I put them in ecological groups that appear, have 5 different families represented, and when possible, I grouped them so they're all in the same genus, so we have close evolutionary relationships. And then you have the bottom one is in its own little group by itself, the Lagodium, which isn't quite going to be included in the comparative results because it's not paired with the native, but I did want to get extra data on this while I was sampling because it is such a problem. And then hopefully that'll kind of provide me with the basis to go back and do more intensive studies specifically of that species. So these species are all fairly common. They represent a wide range of habitats. Some are epiphytes, some go terrestrially, and they grow in different habitats, pine rocklands, hard hammocks, disturbed areas, etc. So as for the invasive species, the new category, the new list of invasive plants for 2011 from the Florida Exotic Plant Council, FLUPC, just came out a couple weeks ago. And so 4 of my current species that I tested are considered category 1. And basically category 1 species are species that are known to be disturbing native habitats and causing ecological damage that has been documented. So it's based on the input of biologists, botanists, and naturalists are going out and looking at these invasive species increasing and actually messing up the habitat for the native ferns. So this project took me across 6 different counties, and as of yesterday, I was collecting at 34 total sites, and then I got Big Cypress today this morning. So a large area, a lot of different types of habitats. Some are in more urban areas, some are like Big Cypress, where you have large swaths of land, and all sorts of different substrate types. So I'm collecting ferns for each species, trying to get as broad a range of how they grow as I see them in the field. So if they are epiphytic and terrestrial, collecting them in both situations. If they're capable, like some, of growing on completely bare rock, getting them in soil, getting them in gravel, etc., whatever I can find. Okay, so the methods are pretty boring, but to do a really basic summation, I collect the roots in the field from living plants in different situations, as I mentioned. I've been making the collections between May, and they'll be finished hopefully tomorrow. Will be my last day of field work for this project. So between May and November, and you then take the roots back to the lab, go through a clearing process, stain them to stain the fungal structures, and then look at them under the microscope. And the way the results are tallied for a project like this is I look at 10 centimeters of root length per specimen, and I'm looking at 20 specimens per species. So a total of 200 centimeters of root length looked at under 40x magnification, and for each specimen, looking at 100 intersections. So you look at all these intersections, which takes a long time, and you tally what's there. So anytime you see a definitive fungal structure that would characterize this is an arbuscular mycorrhiza, you basically tally it. And then you can go through and look at the total root colonization and get a look per specimen, per species, and then overall between native and invasives. So my hypothesis going in was that hopefully I was going to see some difference that could be generalized between non-native species and native species, that maybe these natives were having a different interaction with the mycorrhizas in their environments than the invasives were. Perhaps the invasives didn't need mycorrhizas as much, and that's why they were good at invading all sorts of habitats. Or perhaps on the other hand, they were actually better than the natives at forming these relationships, and that's why they were so prevalent at taking over habitat where natives were already established. So that was what I was thinking going in. So as I'm looking at these results, this is the kind of image you see. Unfortunately, the technique for clearing the roots kind of degrades them. But basically, anything you see in blue is a fungal structure. So the main, this arrow is really not well, I don't know that word. But the hypoattachment is down here. So basically, when you want to categorize something as definitive or arbuscular, this is the outline you can see of the root cell. And this fuzzy mass that looks like a tiny bush in there is an arbuscle. It's basically this branching off of these really, really fine hyphae, and that's where the nutrient exchange actually happens. Incredibly high surface area, and you have the interaction where the fungus is emitting nutrients, the plant is absorbing, and the plant is actually giving the fungus carbon. So that's the symbiotic exchange. The fungus is non-photosynthetic, so it can't produce its own carbon, so it's actually giving it from the plant. So this is what you hope to see to tally something definitively as this type of fungus. And this is in a Terrace system itself, which is a threatened native species in South Florida. Okay, so I won't show you all of the charts because a lot of them don't have any significant difference. But this is one of the charts that's made so far. So the 0 is the Lygonia microphyllum. You can see it's on its own. The blue bars represent native species, and then the red bars are invasives. And they're grouped by pairs, and each pair represents a family. You can see the key over here. So the microphyllum is on its own. And then this axis here, where it says AMF, is the frequency of arbuscular mycorrhizas. So you can look at these numbers as the total root length colonized per whatever group you're looking at. So you can see that some of these are actually really high. Up to almost 50% of the total root length looked at is full of these mycorrhizal structures, which is a lot if you think about looking at the root cells. That's a lot of infiltration. So you would think that the plant is getting some kind of benefit from this if it's allowing this much stuff to live. Sometimes you look at these things under the microscope and it's sort of spaghetti piled on top of the root. And you think, how could the root actually be performing its function with all of this interference, unless it's really getting a benefit out of this association. And then you can see that some of these, in pair 1, these are sword ferns. A lot of times you look at their root lengths and you just see completely blank cells. So it doesn't seem like they're using the mycorrhizas very much, which is interesting. Whether it's native or invasive, it's about the same level. So this is based on when I had 130 samples. I'm going to have about 190 total, so like I said, these are preliminary results. But what I've seen so far and the sampling I've done since analyzing these results is the same pattern is in place. Nothing, there's no outliers and nothing is really changing. So unfortunately, this disproves my hypothesis because you can see within the groups, there's no statistical difference whatsoever between invasive or non-native species and their native close relatives. So what actually is going on here, which is interesting, at least to me, is that there are significant differences between some of the groups. So it seems like the better predictor of these associations of mycorrhizas isn't whether it's native or invasive, whether it's coming into a new habitat or whether it's been there. It's what family of fern it actually belongs to. So there's an evolutionary relationship going on. So that's something that I want to look at more closely, but it does actually go along with the previous hypothesis from a botanist back in the 70s, Bouillard, if you want to pronounce it the country way, that as the evolutionary tree progresses, ferns become less dependent on mycorrhizas. So a lot of these species are so closely divergent that it's kind of hard to really test that, but that's something that I'm going to look at further as well. So I found that colonization doesn't follow a consistent pattern in invasive species. The invasives are more like their native relatives than they are in the other invasives. And the only statistically significant differences are actually between the groups that I put together as far as the ecological pairs or triplets. There is another thing that I did analyze to make sure there wasn't something else going on, and that was the growth substrate. Because since mycorrhizas help provide nutrients and better water absorbance, it follows that if the plant is growing under a rock, or if it's in really poor soil, it might be more dependent on mycorrhizal relationships than one that's already in like a rich, moist area. However, when I analyzed across substrate, it didn't seem to matter for any species. There was no statistically significant difference between anything based on substrate, which was actually really weird, I thought. But, so the thing with this is it's telling us that the invasives are performing in a way similar to the natives, but it doesn't actually tell us how the plants are using the mycorrhizas. So the mycorrhizas are there, but this kind of study can't tell you what they're actually doing for the plant. Now, I did gather oligories from reproductively mature large plants, so they were reproductively successful individuals. So whatever situation they were in, they were thriving. However, it doesn't say whether if the mycorrhizas were absent, they might have still been just as in good a state. So responsiveness to the mycorrhiza, or like the level of colonization or associations, doesn't equal dependence. So I have another project that I'm going to be starting on. probably one of my dissertation chapters. So some of the species, as I showed you in the results slide, have a really high level of mycorrhizal colonization. 40 to 50% of their root base total is colonized by this fungi. But we don't know how it affects the plants. So as I said before, it could be that my hypotheses are still true, that the invasives are better at surviving without the mycorrhizas than the natives, or they're better at using them. So they're getting more out of the mycorrhizal relationships than the natives are. So the next thing that I'm going to do is actually set up a greenhouse experiment, a common garden experiment, and grow some of the natives and invasives in situations with and without mycorrhizas, and look at their growth and their survival and their reproduction. And also look at different levels of nutrients as well to see. So that's kind of the future application of this, to identify more candidate species that might be interesting to look at. So I have a lot of people that help me in various aspects of this, a lot of different agencies. So those are just the main ones. There's others that there wasn't before. And I received a lot of permits from a lot of agencies, which is why I was able to sample so broadly and in so many counties, which is really great. And then thanks to my funding sources for giving me the money to actually buy the supplies, so I didn't have to pay for them out of my poor graduate